Okay, let's take a look at the first equation. I noticed that this quadratic is even numbers. So first I'm gonna do is factor out the 2. So we take out the 2, we've got x squared minus 9x plus 10 equals 0. And I notice that my a value is 1. So the first thing I'm gonna do is I'm gonna do a quick check to see if it factors. Unfortunately, it doesn't because the 10 is positive. If the 10 was negative, that would be a lot nicer, but I'm just going to need to use the quadratic formula. Nothing adds to -9 that multiplies to positive 10. So here we go. I can disregard the 2 because there is no variable with it, and we can just use the quadratic formula with what's left in the parentheses. So we have negative b, so negative 9 becomes positive 9, plus or minus the square root of b squared minus 4ac all over 2 times a. Now I see that I've got b squared is 81 minus 40. 81 minus 40 is just 41. So I've got x equals 9 plus or minus the square root of 41 all over 2. And this is actually 2 real solutions. They're not rational solutions. They are real solutions. When I take a look at number 2, I notice that it's not in standard form like number 1 or number 3. Number 1 and number 3, or number 4 also, are all in standard form. So the first thing I'm going to do is distribute the x and move the 3. So we've got x squared minus 2x equals 3. We're going to subtract the 3. And now we've got x squared minus 2x minus 3 equals 0, which is great because a is 1. And I have 2 numbers that do, in fact, add to -2 and multiply to -3. We've got x minus 3 and x plus 1. If I set my factors equal to 0 using the zero product property, x minus 3 equals 0, add 3 to both sides. X plus 1 equals 0, subtract 1 from both sides. Ooh, that should be 1. And again, I have 2 real solutions. Number 3 is in standard form. It does not start with a 1, so I am going to notice that a is 3, b is -3, and c is 2. And the first thing I'm going to do is do a quick check. 3 times 2, a times c, is 6. Now, there's nothing that multiplies to positive 6 that adds to our b value of -3. So we can't factor this using box or split the middle. We are going to need to use the quadratic formula again. So we have x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's see, b squared is 9. 4 times 3 is 12, times 2 is 24. And 9 minus 24, now I've got the square root of -15. Because I have a negative under the root, this is like the square root of -1 times 15, we can rewrite this as x equals 3 plus or minus I root 15 over 6. And now we have 2 complex solutions because we have an imaginary term. Okay. Number 4, it's in standard form. That's nice. And I notice everything there is divisible by 3. And because the equation starts with a -3, I'm actually going to factor out a -3. So we've got -3 x squared plus 6x minus 5. Now, if this was a -6, No, that wouldn't work either. There's nothing that adds to 6 that multiplies to -5, which is unfortunate. And like number 1, because this 3 is a constant, we can just disregard it. The zero product property does not apply to the -3. It's happy being a -3. So we can just look at this problem as x squared plus 6x minus 5 equals 0. And since I can't factor it, I'm going to go to my next strategy, which is complete the square. I see A is 1 and I see B is even. So that's the strategy I'm going to use. I'm going to start by adding 5 to both sides. And when I do that, I'm going to leave a space. On that space, I'm going to put B, which is 6, divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. 9 is going on my space. Now I can factor the left side to x plus 3, or x plus 3 squared equals 14. Take the square root of both sides. X plus 3 equals plus or minus the square root of 14. Subtract 3 from both sides. And we get x equals -3 plus or minus the square root of 14. Now we have 2 real solutions here. I want to take a moment and point out, if you had just used the quadratic formula at the very beginning, you would not get the exact same solution because it would not be fully reduced. You would have something that would all divide by -3, which is why it's best to take out any common factors at the beginning. Number 5 is not in standard form, and I don't want to put it in standard form because I see it's set up already nicely for square roots. I have a quantity that contains my variable, and it's squared. So my goal is to isolate this. We've got x minus 7 squared equals -100. We can take the square root of both sides. Now, the square root of -100 is 10i. So I'm going to have x minus 7 equals plus or minus 10i. Add 7 to both sides. And we have, again, 2 complex solutions. For our last solving equation, I see that I don't have everything on the same side, and I need to decide where I'm going to write my equation in standard form, on the left or the right. I see that the left side has a 12x squared, and the right side only has 2x squared. Because I really like having a positive leading coefficient, I'm going to choose to move everything to the left side. I'm going to subtract 2x squared and 3. I'm going to do it in the same step. So 10x squared minus 2x squared, 12 minus 2 is 10. These are not like terms, so I'm just going to write them next to each other. Let's do a check. A is 10, B is 1, C is -3, A times C, 10 times -3 is -30. Are there 2 numbers that add to 1 but multiply to -30? Yes, we can use -6 and +5. Now, there are 2 ways to solve this. Use factoring. You can either split the middle or you can box it. I'm going to split the middle first, and then I will box second. So you can just fast forward the video if you know you like to use the box method. So I'm going to say 10x squared minus 6x squared plus, oh, no squared, back up. Boop, 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 boop. Okay. Minus 6x plus 5x. -6x plus 5x. Whoa, wait a minute. I got this backwards. This should be positive. This should be negative. +6. I'm sure when I wrote -6 and 5, you were like, wait a second, that's not right. So now this +1 became +6 and -5, which is 1. I've split the middle term. I'm going to take out my greatest common factor. I go to the second two terms, and like there's not really a common factor, but they're both negative, and I'd really like them both to be positive. So I'm going to take out a -1, and we have 5x plus 3. And so our two factors are 2x minus 1 and 5x plus 3. And so we get values of 1/2 and -5/3, which are two real solutions. Okay, if you'd like to see the box method, I'm going to do the box method now. Obviously, if you like splitting the middle, you are good. So I'm going to keep the same two numbers. I'm going to still use my 6 and -5. And then it's going to be the smallest box ever, guys. Watch this. I'm just going to build a little box here. Here we go. In my top left box, I'm going to put my 10x squared. In the bottom right is going to go -3. And then I'm going to go 6x and -5. And you know that you can choose any number to start with. I'm going to use a -3 because it's prime. And I see both of these are negative. It's a 5. That's unfortunate. So I'll put a -1 here and a +3 here. And then this is 6x. What do I multiply to 3 to get 6x? That would be 2x. This is 10x squared. 2x times what gives us 10x squared? 5x. And you'll see, grab my highlighter tool. Here's my, that's the same. And then that's the same. And then the problem finishes off exactly the same. That concludes part 1. Part 2 says solve each equation and check for extraneous solutions. We need to check for extraneous solutions. Remember, these are solutions that we acquired using correct algebra, but they do not make the equation true because we are taking the square root at some point in these problems. And square root functions do not have a domain of all real numbers. I cannot substitute anything under the radical that I want. It has to be a positive number. So I'm going to start by squaring both sides for number 1. On the right, I want to remember that that's x plus -2 times x minus 2. I'm not just going to square each term. So now I have 5x minus 4 equals x squared times, or minus 2x minus 2x plus 4. That simplifies to x squared minus 4x plus 4. And again, like before, I need to choose which side do I want to move everything to? Well, I see I have a squared term and there's only one and it's on the right. So I'm going to move everything to the right because I like it when the squared term is positive. So I'm going to subtract the 5x and I'm going to add the 4. And that's going to give us x squared minus 9. Why did I not line that up? 0 equals x squared minus 9x plus 8. Oh, this is a good one because what adds to -9 that multiplies to +8? -1 and -8. That works. Apply the zero product property and we get 1 and 8. Let's see if both solutions work. Let's try the 1 first. So I'm going to substitute 1 back in. 5 times 1 minus 4 equals 1 minus 2. So 5 times 1 is 5 minus 4. So is the square root of 1 equal? No, it's not. Bye-bye. So let's check 8. Square root of 5 times 8, that's 40. 40 minus 4 is 36. Square root of 36 is 6. Oh, good, and 8 minus 2 is 6. So that one works. So we only have x equals 8 as a solution. 1 is extraneous. Let's take a look at number 2. Again, we have to square both sides. And again, we want to be careful not to just square each term. We want to do 2x plus 8 times 2x plus 8. So 2x times 2x becomes 4x squared. 2x times 8, 8 times 2x, 8 times 8. Ooh, there's a lot going on here. Let's simplify the left side. That gives us 4x squared plus 32x plus 64 equals 3x plus 13. Yeah, definitely moving everything to the left side. Subtract the 3x, subtract the 13. This gives us 4x squared plus 29x plus 51. Now, these numbers are a little large, and I want to really avoid a quadratic formula situation if I can. So real quick, I'm going to do 4 times 51, which is 204. And I'm trying to think, is there anything that adds up to 29 that will multiply to my 204? And the good news is at least everything is positive. So I'm going to start going, like, make a list. 2 times 10, no, that's not going to work. 3 goes in, but 3 is also probably, let's see, 3 goes into 26 times, 2 left over. That's going to be, no, that's too far apart. 4 goes into 25, so 51. No, we're getting there. 5 doesn't work. 6 will go in. 6 goes in 3 to 23 times, 2 left over. 6 goes to 4. Nope, too far apart. 7 doesn't go in. I think 8 should go in. 8 should go in. 8 will go in. Wait, no, it won't. Let's think. No, because 4, it was 4 and 51. If it was like 4 and another even number, that would go in. 9 doesn't go in. 10 doesn't go in. Will 12 go in? Let's see. I think 12 will go in because 6, if I take this, I make it 2 and 17. 6 times 2 is 12. There we go. So 2 and 17, that adds to 29. So let's go ahead and make a box. I started with split the middle before, so now I'm going to do the box first. So we've got, ooh, that is so ugly. I should use the box tool. Oh, well, too late now. 4x squared, 12x, 17x, 51. No, yes, 51. So, different color. So I'm going to pick this 4 here because I see there's a 17 down here. So I'm going to go 4x. Wait, well, other side. 4x can go here because the 17, that's not going to work. So this is going to have to be a 17. This is a 12. That's a 4. So this is going to become a 3. 30 plus 21 is, there we go, 51. So we have x plus 3, 4x plus 17. Remember, you can always rewind if I'm going too fast or slow me down. That gives us values of -3 and -17/4. Let's check them. Let's check the -3 first. 2 times -3 plus 8, well, that's negative, so that's going to be 2. And then we have the square root of 3 times -3 plus 13. -9 plus 13 is 4. That would check. So this one works. Let's check -17/4. We have 2 times -17/4 plus 8 equals the square root of 3 times -17/4 plus 13. So 2 times -17/4 becomes -17/2. I'm immediately going to write my plus 8 as 16/2. That way, I can add this together, and I get -1/2. That's not good. I immediately know that I'm going to have to do the arithmetic on the other side. That's going to give me no solution because I can't have a square root that produces -1/2. So that one's not going to work. Part 3 says simplify each expression, then classify each number as real or complex. So one thing I'm going to do right off the bat with this first group, make a little room here. is I'm going to remind myself that I to the first is just I, which is the square root of -1. I squared, if I square both of these, I get -1. That's a real number. I to the third, that would be 3 i's. These two become -1. That would be -1i. And then I to the fourth, 1, 2, 3, 4. Well, 2 become -1. Multiply 2 more i's, you get -1. -1 times -1 is +1. Now, I want to remember my rule that every multiple of 4, like every 4 i's that I multiply together, will just equal 1. So I to the 8th is just like I to the 4th. Oh, that came out bad. I to the 4th times I to the 4th, which is just 1 times 1, which is 1, and that is real. I to the 7th is like I to the 4th times I to the 3rd. Again, we're going to stop with this I to the 4th business. This is just 1. And we know that I to the 3rd is -I, and that is going to be complex. When I get to 13, like I'm kind of taking out all my multiples of 4. So 12 is my closest multiple of 4. So that's just like I to the first left over because it's like I to the 12th times I to the first. This is 1. Just I is I, and that is complex. Again, the biggest multiple is 16. And then there are 2 left over. That's like 1. And then I squared is -1. So we have -1, and that is real. Now I need to actually do some arithmetic here. So we've got 4 minus 7i times 4 minus 7i. Do not just square each term. 4 times 4 is 16. Minus 28i. Minus 28i. Okay, -7 times -7 is 49. And then we have I squared. We want to remember that this is now minus 49. So 16 minus 49 is going to be -33 minus 56i, and that is a complex number. Here we have 2 conjugates. We call them conjugates because the 2 binomials are basically the same except one is plus and one is minus. 4 times 4 is 16. 4 times -7i becomes -28i plus 28i minus 49i squared. These two subtract off. 16 minus 49i squared, same as before, except now it's minus 49 times -1. This becomes plus 49. And I end up with 65, which is a real number. This is an addition problem. I'm just going to add my real terms. 4 plus 4 is 8. Positive 7i minus 7i is 0, so it's just 8, and that is real. When I subtract complex numbers, I want to be really careful that I actually subtract both terms. So I'm going to like distribute the negative sign. So I don't want to subtract I don't want to forget to subtract the -7. Bring this guy down. So now 4 and -4 become -8. Wait, becomes 0. I don't know what that was. And then 7i and 7i become 14i. So that is complex. If we were giving it its most specific classification, it would be pure imaginary, but it just says real or complex. Okay, again for number 9, just like number 8, I want to make sure I distribute because I don't want to forget anything. This is going to be -8 plus 14i, and then I'm going to bring down the 4 plus 7i. 4 minus 8 is -4 plus 21i. So this is another complex. Again, let's distribute the negative. Let's distribute this negative. I didn't see that one at first. Well, why is that an 8? Because I'm thinking ahead. -4 minus 7i. So here we just have -8. The i's cancel out. It's real. -3 times 4. -3 times 7. 2 times 4. 2 times -7. Add things together. We get -4 minus 35i. That is complex. Okay, in part 4, it says, given each quadratic, state the factors, the zeros, and the x-intercepts. So I really like number 1. I'm pumped about it. Number 2, I'm less pumped about, because I noticed that number 1, factors. So that's a bonus. I can just go ahead and factor, and we've got x minus 4, x plus 3. So those are the factors. That means the zeros are just going to be 4 and -3. Those are the values that make the function equal to 0. That also means the x-intercepts are going to be 4, 0, and -3, 0. Now, number 2, I'm less excited about because there's nothing that adds to 4 that multiplies to 1. So I'm going to have to rewrite this. I'm going to need to solve it because this is not going to work out for me nicely. So let's start by finding the zeros. So we'll let f of x equal 0. Let's move the 1, and we're going to leave a space because I'm looking ahead here. It doesn't factor, but it is set up really nicely to complete the square. So we could do that. Let's put a 4 on the line because b over 2 squared is 4. So we have 3 equals x plus 2 squared. I'm going to take the square root of both sides. I'm going to subtract the 2. And here are the zeros. They make the function equal to 0. That means the x-intercepts are going to be -2 plus √3, 0, and -2 minus √3, 0. It means that the factors, I'm going to have to write them side by side. I'm not going to be able to write them side by side. I don't have enough space. The factors are going to be x minus -2 plus the square root of 3 times x minus -2 minus. Okay, so those are our factors and our x-intercepts for number 2 in part 4. Okay, and the last problem, part 5, we are given a function with 2 x-intercepts and a leading coefficient. First, we are asked to write f of x in factored form. So we know the leading coefficient is 1. If we have an x-intercept of -1, that means we have a factor of 1, then another one of -7. For standard form, we are just going to multiply our factors together, x times x, x times -7, 1 times x, 1 times -7. So in standard form, we get x squared minus 6x minus 7. To write f of x in vertex form, I'm going to start with standard form. And it's going to go kind of how we found the zeros above. Now, I want to be clear. I know this factors, like I know, but we're being asked to write it in vertex form. So that's like f of x equals a x minus h squared plus k. I'm looking for this format. So the first thing I'm going to do is I'm going to kick the constant over with f of x. So I'm going to add 7 to both sides, and I'm going to leave a space. Because to get from standard form to vertex form, we complete the square. Now on that line, -6 divided by 2 squared is 9. So 9 goes on the line. We have f of x plus 16 equals x minus 3 squared. Move the 16 back over. And here we are in vertex form. What's nice about vertex form is I can look at it and I know the vertex is 3, -16.